morning, good afternoon to everyone, and welcome to our cloud coaching session. Today, we are going to talk about Oracle Graph, and we will showcase 7 key use cases. I am Violeta. I'm very happy to see that so many of you joined our session today. Our speakers are coming from the product management team, and we are very happy to have them here. Ryota and Hans will deliver this session to you, and we hope that you will enjoy it and you will see the importance and why would you use Oracle Graph in your project. As I said at the beginning, our presenters today are Hans and Ryota. I'm very happy to have them here. They will say something more about themselves shortly. One more note on my side, and then I will invite Ryota to take over the presentation, is that since our products are enhanced regularly, in case you would like to watch any of our sessions recordings in the future, keep in mind that you might see some differences in the Cloud Console menu. That was all on my side. Ryota, over to you.
Excellent. So thank you so much, Violeta, for the introduction, and also a warm welcome from our side. My name is Hans Viehmann. As Violeta was just saying, I'm part of the Oracle Database product management team, and I am based in Hamburg in Germany. So I'll be joining you from Europe, and Ryota is joining us from the Tokyo area. Ryota, do you want to say a few words about yourself as well?
Well, nice to meet you. I'm also from product management and covering Asia Pacific mainly, but I'm great. I'm happy to have this chance to talk with and in the EMEA EMEA time slot. Thank you.
Yeah, okay. Thanks for joining us late in the afternoon, your time, right? Bear in mind, everybody, if you ask questions, it is getting close to dinner time for Ryota, so don't go overboard with too lengthy questions. Anyway, I think with that, we can just get started. Let's jump straight in. I'll say a few words at the intro part, and then Ryota will take over, and most of today's session, like all the cloud coaching sessions actually, will be live demo. Ryota's put a fair amount of effort into preparing everything for you. Just a few slides up front. I assume that everybody knows about the multi-model capabilities of the Oracle database, meaning you can use Oracle as a document store, you can use Oracle as an analytics, a spatial analytics platform, or as a machine learning engine, and so on. All of that is what makes Oracle a converged database, and the graph technologies, which we'll be talking about today, they are an integral part in this. And with the graph features, you can actually represent your data, which you typically have either in relational form or maybe in JSON, as a graph. And that basically gives you a different view on your existing data, right? With the use cases that Ryota will be showing in a moment, we'll hopefully make it clear what that actually means. Okay, before we come to that, I have two more remarks actually. One, the graph features are available in all editions of the Oracle database and all relevant cloud services without additional cost. So there's actually no reason, if you have an Oracle database up and running, there's actually no reason not to use them. And two, we are supporting 2 different graph models. In today's session, we will be covering what is known as property graphs, right? But besides the property graphs, we also have a graph model based on the so-called resource description framework, or RDF for short, which some of you may have come across in the context of the semantic web, for example. And we have already implemented support for RDF knowledge graphs many years ago. In fact, going back to Oracle 10G release 2, we are continuing to enhance that functionality, but this is not our topic for today, right? Today, we'll be talking about property graphs. And for us to get an idea of how much experience you already have with graph databases, we have prepared a short poll. Violeta, if you could share the poll, and everybody on today's call, I would really appreciate if you could let us know if you have already been doing successful projects with graph databases, if you have some practical experience, or if you just know the fundamentals, or if you've only heard about databases but really don't know much. or if you don't know anything about graph databases at all and you want to use today's session as a educational session. Okay, I see a lot of people already responding. Great, thank you so much. We are at like 60% of the respondents, meaning there are some people who are either still or already slightly asleep, but okay, we're getting there, 64%. I think I'll end the poll at this point. Let me just briefly share the results so that everybody can see. We have some folks who have successfully done projects with graph database, or at least have practical experience, but the bulk is really only familiar with the basics or don't even know the details. And there are some who haven't heard about graph database. Okay, we'll start slowly, but I hope that today, just by showing you all the practical examples at the end of today's session, you'll have a good understanding of what these graph databases are about. Good. Ryota, I think you can move on to the next slide, because I would suggest that we get started, and let's talk about what graph databases are in the first place, for those of you who are not so familiar with why graphs are useful and what you can actually do with them. Technically speaking, what makes graph databases special is that they treat relationships between data entities as we say, first-class citizens in the database. That makes them particularly useful if you want to discover or if you want to understand relationships. Now, what does that mean? Well, if you look at this example here, right, let's assume you have bank transactions data in a relation format, like with a customer table here, an accounts table, a transactions table. And let's assume that you want to answer two questions. One, is there a money flow between customers named Bob and Charlie? Right, you can see them on the left-hand side. There's Bob, there's Charlie. Is there a money flow? And when I say money flow, that's not a direct transfer between Bob and Charlie, but sort of from Bob to someone else, to someone else, to someone else, and maybe ending up at Charlie. That's the first question. And two, are there clusters of transactions? That is there a pattern of frequent transactions among a group of accounts, while at the same time there are none or very few between that group and the remaining accounts? Now, to answer the first question, in the relational world, you would need multiple joins and self joins between these tables, but you can solve that, but it is not entirely straightforward. Answering the second question is even harder, and that would likely, require some PL SQL which essentially constructs a graph and then determines these clusters. Now let's see how we would answer these two questions using a graph database. Ryota, if you move on to the next slide. In a graph database, you can represent the accounts as what we call vertices in a graph, right? And you can store the transactions in such a way that they show up as edges between these vertices, right? And if you do this, if you look at the little graph on the left-hand side, you can already see from the visual representation that answering the first question about is there a money flow between Bob and Charlie, that essentially just becomes a graph traversal or path finding exercise, right? You look at the account A1 and there's a connection from A1 to A3 to A5 to A4, and that shows you that there is an indirect connection between Bob and Charlie, right? So as I said, that's just a question of path finding. Right, that would be question one. Second question. By the way, you can actually also use that approach to look for other patterns, like cycles or in the graph, which would be representing circular money transfers, right, from account A1 to A3 to A5 to A1 would be like a circular money transfer. These are things which you can find out very nicely, and you can look for patterns from one to two other accounts and then back to one again, and all these kinds of things. Okay, Ryota will show you how that works in just a second. What you need to do in order to do this kind of pathfinding is, of course, you need to map your relational, your tabular data to a graph model. And that's what we'll be demonstrating in just a second, right? That would be the first question. The second question, so the question about clusters of transactions, in order to do that, we would need to use a graph algorithm or some algorithms from graph theory, basically, right? The process is typically known as community detection. And there's a large number of algorithms from graph theory that can actually generally help you to provide additional insights, right? Community detection, like what you can see on the right-hand side, is one aspect, which basically allows you to identify those bank accounts which belong to the same community and mostly transfer money between each other. But there are also ranking algorithms, centrality algorithms, which allow you to determine which bank accounts are more important based on either the number or the nature of their connections to other accounts. Or again, there are pathfinding or connectivity algorithms for you to detect patterns or circular transfers. There are link prediction algorithms, which you can nicely use for like product recommendation and the like. And finally, there are similarity algorithms which help you to find those accounts which have a similar activity, maybe as fraudulent accounts or something, right? Okay, so that was the little bit of intro which I wanted to share with you for those who are not so familiar with graph databases. But as I said, hopefully things will become more clear once we move into the actual demo. And with that, I would like to hand over to Ryota, who will explain the 7 scenarios that he has prepared. Ryota, over to you.
Thank you, Hans. Okay, in the demo part, I'm going to talk about how to create graphs from table data, how to query using graph patterns, how to visualize graphs, and how to run graph algorithms. All the basic operations, how we can manage a graph database. And for explaining the basic operations, I'm going to take this use case, a very popular use case, fraud detection use case in financial services. And then I will take 15 to 20 minutes to introduce all these operations. But for other key use cases, these 6 use cases, maybe we won't have much time for explaining the details. So I will briefly tell you about the use cases and also key technical aspects in those use cases. Okay, then let's move to the third use case. For showing all these demos, I will use this interface, Autonomous Database Graph Studio. So this tool, Graph Studio, is a built-in tool for Autonomous Database. So all Autonomous Database users can use this tool without any setup. And then I put those use cases as notebooks. So let me open one notebook for bank transaction network. I have already run all these paragraphs, so I don't want to rerun these paragraphs right now because it takes some time, and I don't want to get unexpected errors or something. So let me just move to some of those key operations in this notebook and introduce the functionality. So here we can assume that, let me move to the slides for the introduction of this use case. Let me just talk about the use case first. The goal for this use case is to detect suspicious patterns from money transfer network. As Hans already discussed, we can model money transfer network in this way and visualize the money flow very well. So this modeling of the money transfer network is very popular for financial service industry. And typically they try to use this graph for improving machine learning performances, because they often use machine learning techniques to detect suspicious patterns. And using graph and graph algorithms, we can generate more engineered features to help machine learning. For the details of the use case, please look at these links. One is my Medium article, and also you can try the use case using free environment libraries. And also we have some customers' presentations about their actual use. And here I would like to especially introduce you the key technique, how to create graphs from tables. So let me move back to the Graph Studio notebook. And let's assume that account, customer, transaction, that information has already loaded into the database as table format. And the first step to start graph analysis is to create a graph. Here, this is a syntax to create a graph, create property graph. And you can see, as you can see, bank graph is the name of the graph, and you need to list the name of the tables, bank customer, bank account, for creating vertices. So these two tables are the data sources for creating tables. Creating vertices. One is vertices with customer type, with customer ID, first name and last name. And another type is account, and it doesn't have many properties here. For connecting these vertices, we need to define edges. One type is transfer to edge between account and account, which means one account transfers some money to another account. So that such edges can have properties such as date, time, and amount. And another type of edges is owns. So here the source vertex should be a customer node, and destination vertex should be account. So this customer owns this account. So having this create property graph syntax, you can create a graph from table data sources. And once you create this graph, bank graph, you can query against this graph. Let me zoom in, zoom out. Oh, yep. Maybe this is fine. This is one example query of PGQL property graph query language query, which is very similar to SQL, but you can use match keyword here. And then here, this is a graph pattern. The source node here, C represents a customer, and destination node A represents accounts. And these two vertices are connected by an edge E, which has owns type. So the result will be like this, because customer ID should be 10, and customer ID 10 has first name Rora and last name Espinal. So customer ID 10 is Rora, and Rora has owns two bank accounts. Bank accounts 10, and bank account 90. If you like to extend the graph pattern, you can extend the pattern like this. So Rora owns 2 accounts, and you like to get the list of account which got money from Rora's account. So in this case, Rora has 2 accounts, and these 2 accounts sent money to other accounts. Okay.
Ryota, sorry for
Yes.
interrupting. Can you please go with your camera off? Your sound is breaking up a little bit. Maybe it's better
Okay.
if you stop your camera. Let's see if we have an improvement. Thank you.
Okay. How about now? Is there any change or otherwise?
Not really.
Okay. Okay. Give me 30 seconds so that I can
Maybe you can do something with your mic.
yeah, let me move to another network. Give me 20 seconds.
Sure.
Okay. In the meantime, while Ryota is switching over, okay, if it's let's see if it's if it's a bandwidth problem. In the meantime, maybe one quick thing which we got as a question. The question I've seen here is whether the functionality we're showing here is similar to what OrientDB offers, and the answer to that is yes, it is similar in the sense that both work on the basis of this being a property graph implementation. And as it happens, we're just working on 2 OrientDB replacements because customers have realized that there's not much development going on with OrientDB after it's gone open source any longer. So yes, the fundamental concepts are the same, and in fact, we have successfully replaced OrientDB installations with this technology in some places. If anybody needs additional assistance on that, feel free to reach out to us on the boost session after today's call or at a separate instance. You know how to reach us from what Violetta was showing you in the beginning, so feel free to ping us if you need any help on that. Now I hope that Ryota is back.
Yep. Sorry, Hans.
You sound a lot better.
It's perfect now.
It's better. Okay. Sorry about the network quality. Okay.
No worries.
Okay, let me move back to this notebook. And as we have seen, we can write a PGQL query with graph pattern matching, and then having that syntax, we can use, we can query for circular patterns like these 3-hop circular patterns with $500 money transfer each. And how about 4 hops? Yep. And then if you would like to, run pathfinding queries, you can use shortest keyword to find the paths between A1 and A2, right? So that you can get the paths between one vertex and another. So here, account ID 10 and account ID 50, they are A1 and A2, and this keyword shortest can get the path between A1 and A2. Okay, so this is how we can create property graph and query against the graph, then visualize the result. One more thing I need to show you is how we can run graph algorithms. To do that, we can just have this class analyst, and let's say in this case, we would like to know the importance of vertices in the money transfer network. Which account is the most important vertex in the network. In that case, there are a variety of algorithms, but one of the most well-known algorithms should be PageRank, which was invented by Google. And for running PageRank algorithm, we can just run analyst PageRank for this graph, and then maybe we can run some other centrality algorithms so that we can get the result using the PGQL query again, because all these results are stored in the vertex properties, so that you can find that account ID 41. This account has the largest PageRank with 62 incoming edges and 40 outgoing edges. Yeah, if you like to visualize the result, maybe you can change the size of vertices according to the PageRank, and then create this visual. Okay, so this is the basic operation on the first use case scenario. Hans, do you have any additional comment on this?
No, I don't think I have any comments. Maybe just to summarize, what we've seen is how to map relational tabular data, which is essentially what pretty much all of our customers have as the starting point, how to map relational data to a graph. Then the graph is just a view object on top of these tables. With this view object, you can then run pattern matching queries using the query language which Ryota was just showing. And finally, you've seen how to run algorithms. And with Graph Studio, you can relatively easily render these things graphically and so on. Ryota has a bunch of links on this slide here, which I'll put in the chat in just a second. In particular, there is a live labs workshop that goes through all of the setup and all of the individual operations step by step, which you can follow on your own if you're interested. That would be my recommendation for anybody who wants to have a closer look at the sort of more detailed workflow which is behind this. If anybody has questions, do please put them into the Q&A box. That actually helps us to keep track of things and makes answering them a little more simple. And with that, I think we can move on to the next use case, shall we?
Okay, thank you, Hans. So for the list of the use cases, 6 use cases, I'm going to explain them just briefly because of the time. But if you are interested in the details, please look at our blog posts and other materials, ebook to talk about use cases, and also, well, feel free to ask us any questions. So the second this is also very popular use case of graph database, traceability search in manufacturing. The goal is to enhance the performance of trace forward and trace back queries against the complex data in manufacturing. They typically model bill of material data sets and supply chain networks using a graph. So in this case, here, this is a subpart of this part, and this is a subpart of this part. So for composing this product, we need many parts and subparts. And this product is composed in this factory and shipped to this inventory, and then to the sales shops. So for tracing which serial number of the products are coming from which factory and with which parts and subparts with which lot number, for retrieving such data, we need trace forward and trace back search. And having the graph model of this data set, we can run graph traversal queries, which is very performant and scalable against the data size. So the key technique here is how we can use graph traversal query. Okay. Then let me open another notebook.
Yes, while you do that, just a quick reminder or a quick remark.
Okay.
I have just pasted a link to a customer presentation on fraud analytics, which folks may find interesting. So while you're loading things here, maybe folks want to click on that link to get an idea of how real-world customers are actually using our graph technologies for the purpose of fraud analytics. Okay, so back to traceability. Sorry.
Yep. Okay. Just like the example before, we need to create a graph data first, because most cases the manufacturing information, they are stored in relational tables. We need to create a graph from those tables, and this is a graph for a bill of material like this. And then yeah, the actual one is much larger, having a lot of information. And also for supply chain network, we need to build such a graph. And then finally, we need to integrate these two graphs. So for having all these source tables, we can easily create the integrated graph like this. So the actual graph will be like a very large, and then we can run trace forward and trace back queries, but this is against a small data set. So let me show you a little more complex data like this. One particular lot of particular part can be supplied to different parts. So which means this part and another part can have a subpart with the same lot number, right? So this kind of complexity is quite common, and the network will be like this complex, only with 600 edges. But I got 60 million edges graph here, and then I tried some graph traversal searches. So here, as you can see, this is a query. We need to specify one part ID and one lot ID here, because we would like to know whether this part goes which sales stores when we've got any problem in this lot. In this case, we need to specify one part, one starting point, and then we can traverse from P1 to P2 using 1 to 9 hops. So all these vertices are the reachable vertices from this vertex. And this query is very performant when you use a graph database. So having this interface, you can change the lot number, and you can run graph trace forward search and trace back search to find problematic part, and also the all the destinations affected. So this is the second use case in manufacturing. Hans, any comment here?
I haven't seen any immediate questions on traceability in manufacturing in the Q&A box, but maybe just to highlight the key thing again here, which Ryota was showing, right? It was primarily he was primarily looking at how to represent these graph traversal queries using the match clause. And again, I'll paste the links in the chat in just a second. So I think with that we can move on to the next.
Okay. The third use case is investigation, especially in public sector customers. In this case, graph database itself is used in national intelligence, police organizations. But in this case, this is a case when we need to detect potential conflict of interest in organizations, especially public sector organizations. To do that, we need to model various information, not only about bank account, but we need to correct more information, variety of more information in a heterogeneous graph, and then find cycles with unknown length. So in this case, this person declared, submitted this declaration form to declare the personal interest against this supplier. But at the same time, this employee has purchased has approved the purchase from this supplier. So in this case, this is a potential conflict. So for detecting conflict, finding cyclic paths is quite useful. So in this example, key technique is how we can use pathfinding query. Oh, sorry. Let me then open another notebook for conflict of interest. So in this case, we need to have more types for vertices and edges: employee, declaration form, supplier, purchases, and the relationship between them. Then we can have those output. So here, in this case, Kerry approved this purchase from this supplier, and Kerry has personal interest against this supplier. There's no problem here, but eventually we would like to find the cyclic paths like this, right? So yes, if you can if you can write down the path in this way, yes, you can get the patterns with fixed number of hops. But at the same time, you can add more and more heterogeneous information into this graph, like the location similarity, and whether they are sharing the personal telephone number and other information, so that having more and more variety of information, maybe eventually you'd like to run shortest path query to find any cycles. So in this case, you can run shortest path query to get 50 potential shortest cycles from E1. E1 is this target employee Claudia, and also the and E2. E2 is also Claudia in this case. E1 equals E2 because we would like to get cycles, and you can have one or more hops between the starting point and the end point. And then you can get 2 cycles here. Claudia share the emergency contact with Richard, and Richard is living close to this supplier. The addresses are close here, and the supplier's purchase is approved by Claudia. In another case, they're also sharing the contact, and Erica declared the personal interest against this supplier and approved by Claudia. So such complicated patterns can be also found by shortest path queries. So that's investigation use case.
Right. Again, I don't think we have open questions, but you covered one aspect which was actually a question previously, which was about location. So taking into account location, which is great because that's another feature of the Oracle Converged database, which we can use here, right? Using the spatial features, we can determine where somebody is living based on their address, and then look at, okay, how far is that apart, and we can create an edge from that distance. That may be a useful piece of information which otherwise is not being taken into account. And what you just saw from Ryota's demo was a number of things. One was the fact that we mapped multiple source tables to the graph, right? You have all kinds of different information all coming together in one graph, right? And every edge and every vertex represents potentially something different, right? Which kind of reflects the schema flexible nature of the graph. That's an important thing to take away from this demo. And as Ryota was showing, we have this shortest path capability in the match clause, so that you can determine connections and paths. And in order to represent them, there's this 1 row per step representation, where I think in the interest of time, we're not going to go into the details of that. Right, we're getting close to the top of the hour, and we have a few more things to show. So I think with that we can move on to the next use case.
Okay, thank you, Hans. Just briefly then, post one critical path analysis in IT departments. The goal is to find the critical path, most time-consuming path in the large job network. Well, imagine that you have a large job network, and you have to the workflow has to be completed in the nighttime job batch, and in that case, you have a limited time, and you always have to be care about the longest path, the most time consuming path when the data size is getting larger and something. So for that, we can model jobs of the workflow like this with their elapsed time from log information using a graph, and then run a shortest path algorithm to find the critical path. So it's not like shortest path but longest path, but for getting the longest path, we need to use a shortest path algorithm. So we need to have a kind of variant of built-in algorithms, and we can use a built-in algorithms of our product, because Oracle Graph itself has more than 60 built-in algorithms. So let me open critical path notebook, and yes, as always, we can create a graph from table information, maybe using log output, and then create a graph like this. And then, as you can see, these are the jobs, and the numbers in the edges elapsed time. And for finding the most time-consuming path, maybe some of you might think that we can use shortest path query like this, having but actually shortest path this shortest path query in PGQL uses Dijkstra algorithm behind, and it doesn't accept minus negative values for weight. So we need to use another shortest path algorithm, which is let me move to this part. Yeah, which is called Bellman-Ford. So Bellman-Ford, here, as you can see, the built-in functionality of shortest path in PGQL, only positive edge cost are supported in shortest path or cheapest path query code. So you need to use another algorithm called Bellman-Ford, and Bellman-Ford is included in the list of built-in algorithm of the Oracle Graph. So you can use this and then get the result of the longest path, so that you can use that for highlighting the result in this way.
Ryota, maybe you want to just quickly show once how you can change the visualization in the notebook, just so that folks know which button to click if they want to, I don't know, change the graphical representation of the vertices or add some highlights or something. Just, just once so that folks know.
Sure. The trick is that in the calculation, according to the graph algorithm result, Bellman-Ford shortest path algorithm result, I added edge property here is critical, true or false. And then for those edges with this new property with true, we can change the visual using this button. We can open settings and go to highlight and see, as you can see, yes, for the edges with is critical property equals true, we can change the color of the edges.
Excellent. That was just the one thing I thought might be worth highlighting, so that at least everybody has seen it once, how we can play around with the visualization. There's tons of options to graphically represent the graph, but again, in the interest of time, I think we don't have the possibility to show everything. Again, the hint: go to the live labs, try things out on your own. That would be my recommendation. All right, Ryota, I think we can move on to the next. There are no open questions at the moment.
5, 6, 7, 3 more. So recommendation engine, especially in retail industry, goal is to create personalized recommendation. Maybe you're familiar with such recommendation engines. To do that, we can model purchase histories like this from tables, and then run link prediction algorithms on the bar-type graph like this. So here, you can imagine that we can create a graph like this from the purchase history information, customer here, product here, and sales table is here. And then if the edge between this person and this product is not yet there, maybe link prediction algorithm can say that we potentially there's a potential edge between between these two vertices and between these two vertices. So this is a basic recommendation algorithm. So the question is how we can use link prediction on Oracle Graph. So there's a LiveLab workshop available for this use case movie recommendation. So let me just show you the key point. Oops, sorry, another one. Yep, create property graph, movie recommendation graph, and then customers and movies, bipartite graphs. And then having that graph, we can run algorithm called personalized salsa, which is a well-known link prediction algorithm against bipartite graph. And then we can have a list of titles, movies, with a larger personalized salsa scores. So in this case, we can run recommendation, or we can run this algorithm against one particular customer with this ID, and then so that we can get the list of scores, a list of movie titles with higher scores. And then if those movies are already watched by this customer, maybe we don't need to recommend them to this customer. So I use not exist keyword here to remove all these movies. And then this is the potential recommendation for this customer. So using the same graph, we can use different algorithms like personalized page rank or photo for all, or even a deep work or any other graph machine learning related algorithms for enhancing the recommendation.
Great. I think that covered the main aspects here. There's one thing which you can already see from the mapping here, which may be interesting for anybody coming from a relational background, right? If you have an end-to-end relationship like here between customers and products, right? One customer has purchased one or more products and one product is purchased by one or more customers, that end-to-end relationship can be resolved in two vertices and an edge, where the end-to-end relationship, the table here, the sales table, the fact table, just becomes an edge. So that in terms of modeling may be interesting, so that you end up with this bipartite graph, which Ryota was referring to. And then there's loads of algorithms, as Ryota was showing, in the engine, which you can use for this purpose. All right, good.
Right. Yeah, thank you, Hans. Well, yeah, we don't need to convert all these information into graph, but if you need a recommendation, maybe you can take only 3 tables here as source tables in this case. The use case is how we can detect hidden relationship between passengers of my internet connection looks stable. Hans,
that's okay. Yeah, we lost you for a half a second, but okay. I think it completely recovered. No problem.
Yep. So this use case is to detect hidden relationships among passengers of flights. This is an actual use case in Europe, and here in this case, they created homogeneous graphs using table aggregation, which means in here, this is a bipartite graph with trains and passengers boarded. But we actually want this social network between among passengers and passengers. If they boarded the same planes 3 times in a week, maybe they know each other. So once we create such a social network, and then if you have any like a block list or something for the for suspicious people. Maybe you can find other related people from those suspicious people. And of the graph convert here to here, how it works. Here, the original graph boarding can take passenger information and flight information and boarding information, which
sorry,
stored
Ryota,
as edges between passenger and flight.
Up a bit again.
Yes?
You're breaking up a bit again. Can you just
Okay,
repeat that,
okay.
Bert? Thanks.
Okay. Okay, so here this is the boarding graph with passenger and flights, and boarding information which can be captured as edges between passenger and flight. So we can create this graph like this, but we would like to eventually get the graph between passenger and passengers. So for that, we would like to create boarding together graph, another graph. And for that, we can run simple SQL queries to get the information whether one passenger ID1 and another passenger ID2, they have boarded together on any airplanes and how many times. And it is easy to create such an aggregation query.
Okay, looks like we're losing Ryota here. That's interesting. So okay, so you're back.
So,
okay, I was just stepping in here. So we had a dropout for a few seconds, where you were just explaining that the SQL query, essentially, that we're using a SQL query here to aggregate the relevant information. I think that was the gist of it. Did you say anything else?
Nothing.
Okay.
Yeah.
All right. So then, based on that, you can then continue.
Mm-hmm. And then once you got this social network and having the information of suspicious people, passengers, maybe you can analyze the graph as a social network, and this person is closer to other suspicious people, called here, or according to the size of the vertices. And you can also find the people in the path between one suspicious person and another suspicious person. This is an example.
Yeah, and I think it is again worth highlighting the fact that we can combine the power of SQL with the graph query language here, which means that for any kind of pre-processing, you can nicely use all the features of the database. Okay, I think Ryota, you're back. I was just summarizing again.
Okay.
Okay, I hope that the internet connection lasts for the next few minutes, because we're almost done.
Almost done. Final one is employee collaboration analysis in HR departments. The goal is to analyze the network presence of employees. First, we can create a social network from meeting events, whether this employee and another employee have attended in the same meeting, how many times, so that we can create a graph according to the meeting events in our calendars. And then we can calculate centrality scores based on the network connections, and then store the scores in the database first and analyze the time course changes. Here, I would like to show you that we can store the graph algorithm result back to database so that we can analyze the such scores using relational database again. In this case, one person, its network presence, like PageRank, is increasing in time course.
While the notebook is opening, there were a couple of questions about the links which we've shared, and I'm just putting a couple of links into the chat with additional resources. And most of the Medium articles which we were referring to in the previous chat messages can be found under the link which you'll find in just a second. Ryota, sorry, I didn't mean to interrupt you.
Problem. Okay, the final notebook, employee network. Yes, as always, we can create a graph empnet using 3 tables: employee, meeting, and the attendance of the meeting for all employees. And then, yes, the graph will be like a bar type graph like this. And then we can convert that graph into social network, like homogeneous graph between employees and employees, like this. And maybe we can have the number of meetings they have attended together, right? So having this graph, we can calculate the importance of those vertices in the network. So CEO has this PageRank and director has more PageRank because they are in the communication path between CEO and managers and etc. If those members have more interaction with the other members in other organizations, they must get more and more PageRank scores or other centrality scores. So after calculating such scores, using here, using PageRank or between centrality, we can get these scores, and then we want to store the results back to the database, right? Back to database as a table empnet score day 1 and day 2, sorry, day 0, day 1, day 2. And then once you corrected the time course information of the network presence of those employees, maybe you can find that one particular employee is increasing their network presence in time course, let's say after their entrance into the company, or otherwise some of them might be decreasing their presence in the network, which might be problematic sometimes. So this is a potential analyst workflow for HR department. Hans, did you find any more questions?
Good.
Okay.
No, I think there are no open questions. I actually quite like this employee collaboration use case because it allows you can use that for all kinds of purposes, right? In project teams, you can figure out, okay, who is the only link between 2 project teams, for example, or who is particularly important. So lots of interesting analytics possible on these kinds of social networks. But as we are slightly over time, I think we should come to a close.
Okay, as summary. Yes, graph database is useful for graph-based pattern matching, graph algorithm, and intuitive graph visualization. And I introduced how to create graphs from table data, query using graph patterns, visualize graph, run graph algorithms, using autonomous database, Graph Studio. But the same operations can be done using all Oracle database editions and deployment. And there are many industry use cases. Each use cases have practices and techniques. So please check out our articles and future articles and demos in our channel.
Yeah, good point. I have just pasted particularly the medium.com link to the blogs, the one which is on here also, medium.com/tag/oracle-graph. That is the article, that is the link which will get you to many of the articles which describe in much more detail what Ryota was briefly explaining in today's session. So that one is the one which I wanted to particularly highlight. The rest is also on the Live Labs at developer.com, oracle.com/livelabs. If you search for graphs, you'll find a ton of Live Labs workshops. Sorry, Ryota, you wanted to summarize this.
Yes, yeah, there are a lot of information on the web, publicly available, and you can try all these scenarios using free environment. And so yeah, please try. And also SQL PGQ, this is a new standard of SQL having graph pattern matching, which is supported in Oracle Database 23c. If you are interested in, please try out with the freely available 23c edition. Okay.
We've covered pretty much everything. Thanks a lot for everyone staying with us till the end. Hans, Ryota, thanks a lot for being here. Thanks a lot for this great presentation and demos. We hope to see you again soon in cloud coaching sessions. And we hope to see everybody soon. With that, I would like to end this call. Thank you. Enjoy the rest of the day and see you soon. Bye-bye.